All right, so wait, where was I in the thing? Oh, right. So right, we ended off at, well, if I measure, okay, we ended off at, if I measure the resistance. A brand new capacitor. What is the resistance of the dielectric? Like, what is the resistance of a capacitor? Now, I was doing some testing. It was kind of complicated because I wasn't measuring the resistance directly. I was doing it based on the RC time constant of the capacitor. I made a capacitor with parallel plates, and the capacitance was like 4 nanofarads or something, and then I charged it to like 60 volts and then watched the voltage drop and then used the oscilloscope to find the time it took. But the problem was that the capacitor would discharge very, very quickly after it was charged. So I'd charge it up and then I'd like just take the voltage off the capacitor and it would discharge. And it was really interesting because I was not expecting that to happen, right? I would expect the capacitor to hold its charge because like, where is it going, right? So I pulled out some capacitors from the parts wall and there was the same effect on a capacitor of equal capacitance from the one that I physically made. And so it had the same effect. So I was thinking, well, it must be something like it's discharging through the air. Like that was my initial conclusion. It must be discharging through the air. So then I did the calculation of what the resistance would have to be of the air in order for this to be what's going on. But the multimeter overranges at 50 mega ohms or something. So the calculation came out to about an order of magnitude less than that. That's the best case scenario. That's how far I'm off. I have a sense that the air must be some fairly significant amount more than 50 mega ohms. That means that what's happening is not the air. But then I was reading here and like manufacturers rate their capacitor dielectric sometimes in ohms. And that was really helpful, but it meant that I should have directly measured the resistance of the capacitor, which I never did. If I do that and the resistance is more than 50 mega ohms, then I would be completely confused because I have no idea what would cause that. All right, so wait, where was I in the thing? Oh, right. So right, we ended off at, well, if I measure, okay, we ended off at, if I measure the resistance of the capacitor, we can see that it has over, and I have to make sure that I don't have my hands in there because I don't want to measure my resistance. We can see that the resistance is over 50 mega ohms, which is the case where I was saying, well, I have no clue what's going on. So what is actually going on? Well, it turns out there was actually 3 ways that this capacitor could discharge. Either it's leaking current through the paper, it's leaking current through the air, or it's leaking current through the scope. So the act of measuring it is actually discharging it. And we know that because if we go and measure the resistance of the scope, we have 9 mega ohms or 10 mega ohms, and that's exactly what I calculated it should be using the RC time constant of the capacitor. So I was able to measure using the multimeter what the capacitance of this capacitor was, and then I charged it to 60 volts and then removed the power supply, and then I got this discharge curve, which is what is, so this is the curve of the voltage as the capacitor is discharging, and based on the time that it's taking to discharge, I can use the RC time constant to calculate what the resistance is that it's discharging through, and this is the resistance of the scope is that resistance. Ta-da!